need to start the oxidation, reduction, and redox reaction. Now, can you kindly tell me that do you want to do this chapter right from the beginning, or do you want me to teach you some specific topic?
Yes, please.
No, no, I'm asking you that do you want me
From the
to
beginning
teach
is
the
fine.
whole chapter starting from the scratch? All right, fine. Okay. Okay. Got it. Okay. Okay. So we are going to start the oxidation reduction chapter. So there are three things in it: oxidation, reduction, and redox reaction. All right, so we are going to deal these three terms one by one. All right, so starting with the first one, that is oxidation. Now, as far as oxidation is concerned, there are four definitions of oxidation, and if any one of them applies, it is called as oxidation. Sometimes only one definition applies, sometimes two definitions together they are applied to a reaction. Even then, it is called as an oxidation reaction. Are you getting my point, right? If you want to see the oxidation in real life, then rusting is the example of oxidation. Rusting of iron is an example of oxidation. So this is the example from daily life. All right. And what is rust? Rust is iron 3 oxide, Fe2O3. It's an oxide of iron. So when actually iron combines with oxygen in the air and water, in the presence of water, it forms Fe2O3. Now, Fe2O3 is actually rust. This is rust. And because why this reaction is called as oxidation reaction, Michelle? Because oxygen is being added. Can you see that oxygen is being added to iron to make iron oxide? Is it clear? So this is called as oxidation. Are you getting my point?
Yep.
Yeah. All right, please be very careful
Yep.
because this chapter is really very important and students sometimes they find it difficult, right? So please, your whole concentration should be towards the screen and listen to me carefully. Thank you. All right, oxidation. As I told you earlier, that the best definition or the simple definition of oxygen is
I think
addition, or
I think
oxidation is
my
addition of oxygen, right?
voice is like I think my voice is like coming delayed.
Sorry.
I think my voice is coming to you
Michelle, can you?
delayed.
Yeah, I know, I know. Can you hear me clearly, Michelle?
I can hear you, but my voice is coming delayed. So then when I'm
Oh,
responding late, it's not me, it's the voice coming late.
okay. Oh, it's okay. It's okay. It doesn't matter. All right. So oxidation is actually addition of oxygen, right? So the first definition of oxidation would be, as you can see, that oxygen is added to iron to make iron 3 oxide. So the first definition is addition of oxygen is called oxidation. The second definition of oxidation is removal of hydrogen. Removal of hydrogen. So, if hydrogen is removed from any reaction, that is also called as oxidation. Now, the third definition is loss of electrons. Loss of electrons. When in a reaction electrons are lost, that is also called as oxidation. And the last one is increase in oxidation number. Increase in oxidation number, that is also called as oxidation. Now, even if any one of it, doesn't mean that all the definitions will be applied for the oxidation. No, even a single definition of oxygen is applied on any reaction, that is called as oxidation. So I am going to apply one by one all the definitions here to show you. So the very first definition, I have already done that in front of you, that what is oxygen? That is, oxygen is gain of oxygen. That is Fe plus O2 Fe2O3. So put 2 here and put 3 here. So this is 3 by 2. Yeah. So this is the definition. This is the first equation. And this is related to this one. That is, it is oxidation. I hope you are getting my point. Is it clear? Yeah. All right. So now oxidation, the other
Yep.
definition of oxidation is removal of oxygen, is also called as oxidation. So that means that if hydrogen is being removed, that is also called as oxidation. Okay. So if you take the example, I'm going to give you the example of removal of hydrogen afterwards. Then comes the loss of electron, that would be like this. Loss of electron. I'm leaving the space for this. I'll come later. I'm going to describe it later. First, I will leave the space for it so that it will make sense to you. Now, I'm coming to loss of electron and then increase in oxidation number. Now, loss of electron means, for example, you know that metals are reactive. The reactive metals, what they do, they lose electron. For example, magnesium. Magnesium solid will lose electron to form magnesium ion, like this. So what is happening, sorry, as you know that if the electrons are written after the arrow, they are lost. So these two electrons are being lost. When the two electrons will be lost, that is called as oxidation. All right, is it clear? All right.
Yeah.
Okay, now the next one is that that is increase in oxidation number. Actually, you can give the same example, like in this example, you can take the same example here. Magnesium is with zero oxidation number, right? Now it is changing to +2. So that is from 0 to +2. This is called as increase in oxidation number. So this is an example of oxidation. Are you getting my point? This is an example of oxidation.
Yeah.
Right. So now, as far as the other, even you can take this example, applies for both. This applies for loss of electron, and it is also for increase in oxidation number. Increase in oxidation number. All right. So this is also called as oxidation. I hope it makes sense to you, right? Is it clear, Michelle?
Yeah.
Anything which is bothering you, please tell
Yep.
me
Yep.
right now. All is fine?
No.
All right, fine. Now the
Yeah.
next one, the example of removal of hydrogen. This one, removal of hydrogen. I'm going to color code it. Addition of oxygen. This one, loss of electron. This one. And if you want me to write a separate equation for increase in oxidation number, this could be sodium solid changes into sodium ion plus electron. So that is from 0 to +1. So this is also an example of increase in oxidation number. So these are color coded now. Now the last one, that is removal of hydrogen. You can take the example like this. H2S plus chlorine. Now it is going to form S plus HCl, that is 2. Now have a look. Actually, what is where are you can see oxidation from hydrogen sulfide. What you can see that hydrogen has been removed. So this is an example of oxidation, because I gave you the example that removal of hydrogen is also called as oxidation. So this is the example. Are you getting my point, Michelle? Okay. Any confusion
Yeah.
in these definitions? Please tell me right now if something is bothering you. All right, good. Now comes
No.
the other one, that is reduction. So
Mm,
we are going to do reduction now. So this is oxidation. Now I'm going to do reduction with you. Now, opposite to it, reduction. Whatever is written here, you will write the opposite of it, and that will be the reduction. So, first, if I am writing addition of oxygen, so the removal of oxygen will be called as reduction. So, I am going to write, I will underline these words: addition, removal, loss, and increase. So I'm going to write the opposite of it. So addition of oxygen, that would be removal of oxygen. That is called as reduction. All right. Okay. Okay. Next would be, the other example would be, now this is removal of hydrogen. That means addition of hydrogen would be reduction. So again, addition. Here it is. Addition of hydrogen. Now, the third example, loss of electron. So, Michelle, what would be the opposite of loss? Gain.
gain.
Gain of electron is called as reduction. Well done. And the last one is increase. What is the opposite of increase? Decrease. Decrease in oxidation number. So that would be again reduction. So these are the definitions of reduction. So what you need to do is simply memorize the definitions of oxidation, all the four definitions, and you can easily memorize for reduction. So there is no need to separately remember these definitions for reduction. If you know about oxidation, reduction can be easily done. Now the equations. So when we talk about the equations, how can you write it? Now have a look. The first one is removal of oxygen. So let's give the example, removal of oxygen. So when oxygen is removed, then what is it? It is called as oxidation. All right. So how can oxidation be, oxygen can be removed? Can you give me an example in which oxygen is removed? Yeah, Mission? Think about it.
Um.
Any example in which oxygen would be removed?
Let me think. Let me think.
Addition, removal of oxygen.
H2O.
H2O changes into, that would be electrolysis. That would be electrolysis.
Oh.
Think about any other example.
Um. Let me think. I don't know. What could it be?
No, no example comes to your mind. Hmm?
I don't know. What could
That
it be?
Uh, all right. So, for example, I'll think about it. I'm going to go further along. Just think about it. Simply, you need, all right, I'll give you the example. Removal of oxygen. Now, let's suppose if you take Fe2O3 and you react it with carbon monoxide, you are going to get the product which is 2Fe plus 3CO2. Now have a look. Have a look. What is happening in this? Can you see that from iron oxide, iron has been, oxygen has been removed? Can you see this? That now here iron is with oxygen. In the product, iron is alone. So oxygen has been removed. So what is it? It is actually removal of oxygen. So this is called as a reduction, and CO is changing into CO2. So that means CO is gaining oxygen. So look, CO and CO2. So it is gaining oxygen and it is called as oxidation. Are you getting my point?
Yep.
Yes, removal of oxygen. Okay, now addition of hydrogen. Now the next is a reduction is addition of hydrogen. So now I'll this example addition of hydrogen. So take the example. If you see this example, I'll take the same example. H2S plus Cl2 S plus 2HCl. Can you see that in chlorine, hydrogen has been added? Yeah, in chlorine, hydrogen has been added. Okay, so this is an example of reduction. And at the same time,
Mm-hmm.
sulfur is losing hydrogen. So at the same time, this is actually what? This is oxidation. All right. And when Michelle, oxidation and reduction, they take place simultaneously, this is called as a redox reaction. Okay. This is called as redox reaction. All right. I hope it clearly makes sense to you. Okay. Is it fine? Okay. Now, next is
Yep.
gain of electron or decrease in oxidation number. Now, I know it's very hodgepodge. Gain of electron or decrease in oxidation number. So let's suppose when copper ion will take two electrons and changes into copper solid, so this is called as gain of electron. So this is an example of reduction, that is gain of electrons. So this is also an example of reduction. And what is now the last one, decrease in oxidation state. I hope you can see that, oh dear, you can see that plus 2 is changing into 0. So there is a decrease in oxidation number, that is also called as reduction. Now I'm leaving it for a while in front of you so you can have a clear look. Now, is it all fine?
Yeah.
Is it all fine? Any confusion? So I can
Yeah.
explain it again. In any reaction, if you have any confusion,
No.
please do ask. I'll explain again. Okay. If all is clear, then we will move
Okay.
to the next one. That is so redox reaction. I'm repeating again. In this reaction, redox. Now the next term is redox reaction. What is a redox reaction? When oxidation and reduction is taking place simultaneously, the reaction is called redox reaction. Redox reaction. Now I am going to give you the same example. That is this one, Fe2O3 plus, here it is, plus CO plus CO changes into 2Fe plus CO2. Now I am giving you the same example. So here we are going to put 3. 3CO here. All right. So this is the example. Now have a look what is happening actually. That is iron is changing into iron oxide is changing into a iron. So that is called as loss of oxygen. And loss of oxygen is called as reduction. And CO is changing into CO2. That is called as addition of oxygen. So that is called as oxidation. So in the same reaction, oxidation and reduction, they are taking place simultaneously. So this reaction is called redox reaction. This reaction is called a redox reaction. Okay. Now, now one thing more. I am going to write something which is going to help you a lot in understanding the reducing agent and oxidizing agent. Now, there is a trick. The trick is with oxidation, write reducing agent, opposite reducing agent. And with reduction, write oxidizing agent. Now, whatever are the definitions of oxidation, the same are the definition of reducing agent. And whatever are the definitions of reduction, same are the definitions of oxidizing agent. Now, let me, student, they get very confused when they differentiate between oxidation and oxidizing agent. So I'll tell you how to do that. Now, listen to me very carefully. When you travel overseas, then what happens? The traveling agent makes all your plan. That he tells you about the flight, when your flight is going to take off from the specific airport, when it is going to land. So, he gives you the whole itinerary, and it tells you clearly that that itinerary tells you clearly that you are going to travel through which airline and on which airport, which country, everything. So traveling agent makes the itinerary for you. Traveling agent makes you travel. He doesn't travel. He stays there, but he makes you travel. So same is the case with oxidizing agent. Oxidizing agent oxidizes the other species, and itself it gets reduced. So, as traveling agent helps you to travel, so oxidizing agent helps the other species to get oxidized, right? It itself, oxidizing agent itself, it gets reduced. Itself, it gets reduced. Same goes for the reducing agent. As indicated by the name, reducing agent. What is the meaning of agent? Which compels the other thing to do that thing. For example, reducing agent it will reduce the other species. It will reduce the other species. So that is called as reducing agent, and itself it will get oxidized, and itself reducing agent itself it gets oxidized. Now, Now check this. I have written here reducing agent. So that means if something adds oxygen, that is a reducing agent. So have a look here. What is adding oxygen in this equation? Now tell me, please. Reactant side. What is adding oxygen in it? Towards reactant side, which species is adding oxygen in it?
Mm,
It's right in front of you, beta, towards the reactant side. Which species is adding oxygen in it? How many species are there, Michelle, on the reactant side? Michelle, how many
Why are you
species
saying
are there?
species? I'm confused.
All right. Reactant. How many reactants can you see? How many reactants can you see?
Oh, true.
Two. Which reactant is adding oxygen in it?
3CO2. I mean 3CO.
Very well done. So this is carbon monoxide. It is adding oxygen in it. So this is a reducing agent. Is it clear? Have a look. Addition of
Mm-hmm.
oxygen it means reducing agent. So as carbon monoxide is adding oxygen in it and CO is changing into CO2, so CO is the reducing agent. Are you getting my point?
Yep.
All right. Now, what is the definition of oxidizing agent? Removal of oxygen. If if a compound is getting rid of oxygen, that is called as oxidizing agent. So, which compound or which thing is getting rid of the oxygen? Can you tell me? Which compound towards the reactant side is losing
Um,
oxygen?
the one that
Towards
so it'll
reactant
be, let
side.
me think. No, three CO2. I mean 3CO.
No, no, towards the reactant. Is it losing oxygen, Michelle? It is gaining
No,
oxygen,
no,
beta.
it no. 3CO is gaining oxygen. This is what I
I'm
meant.
asking, no, no, I'm asking which compound is losing oxygen. It's written in front of you, Michelle. Which compound is losing oxygen? Michelle,
Which compound is losing oxygen? It'll be
in this equation towards the reactant side, which compound is losing oxygen? Well,
Fe2O3.
well done. Fe2O3 is changing into what? Fe2O3 is changing into what?
To Fe.
Fe. So that means oxygen is being lost. Oxygen is being lost. So when oxygen is being lost, Michelle, this is the oxidizing agent. This is very important what I am telling you.
Yeah.
This is very important. So this is the oxidizing agent and this is the reducing agent. Is it clear now? Okay.
Yep.
So you can write like you can remember like this oxidation means whatever are the definitions of oxidation, same is the definitions for reducing agent. Whatever are the definitions of reduction, same is the definition of oxidizing agent. Is it all clear? Okay, so now we are
Yep.
going to, okay, now I will give you some question and then you need to tell me, okay? So just give, I am going to stop sharing for a moment and then I am going to post the question and you are going to give me the uh, answer, okay? So just wait for a while. All right, Michelle, let's do these questions. Now you need to tell me. The following questions are about this reaction. Now, this is the reaction. Now, you need to tell me which element
Mhm.
has gained electron, which element has lost electron, which element has been oxidized, which element has been reduced. And a half equation, we are going to do the last three. All right, I'm leaving this for a while because we haven't studied it yet. And then you need to tell me which is the oxidizing agent and which is the reducing agent. Now take your time and please tell me, all right?
Okay.
The first one, which element has gained electron? Specifically, I am talking about this equation, so you need to concentrate on this equation. Okay, please concentrate on this equation.
Okay, that's fine. I'm just looking. Is the answer BR?
For the first one, gained
Yep.
electron, yes. So bromine has Br2 has gained electron, 2 electron to change into 2Br negative. Yes, good, well done. So which element has gained electron? Bromine. All right. Which element has lost electron?
Um.
Which element has
The
lost electron?
Is it
It is
CA?
yes. Ca is, what is the oxidation number of Ca here? 0. And it is changing
Mm.
to what? Plus 2. So it is losing electron. Yes. So which element has lost electron? Calcium. Calcium has lost electron. How come? This is gas and this is uh, iron, gaseous ion. Now, this is how come Ca solid changes into Ca2 plus gas plus 2 electrons. All right. Now, the third question. Well done. Good going, Michelle. The third one. Which element has been oxidized?
Um.
What is the definition of oxidation, Michelle? Here it is. These are the definitions of oxidation. So,
Hmm.
which
The answers B C
Ca,
A
well
C
done.
A C A.
Yes, well done. Which element has been oxidized? Calcium has been oxidized, that is Ca. How come? Because it is losing electrons. So when something is losing electron, that is called as oxidation. Which element has been reduced? Which element has been reduced? Now, what are the definitions of reduction? These are the definitions of reduction. Removal of oxygen, addition of hydrogen, gain of electron, decrease in oxidation number. So now check here. Which element has been reduced? Michelle, can you hear me?
BR.
Br. So you will write bromine. Bromine. Br. Well done. What is the oxidizing agent? What is the oxidizing agent? Michelle?
The oxidizing agent. I'm just thinking. Is it BR
Well done.
two?
Good girl. Br. Br2 would be the oxidizing agent. And now what is the reducing agent? This is very simple. What is the reducing agent?
The CA.
Ca, calcium. This is the reducing agent. Well done. I hope you have got the idea about oxidation and reduction and oxidizing agent and reducing agent. Is it clear? So now the conclusion is, I'll write the
Yeah.
conclusion. Conclusion. Now, always keep this thing in mind. The conclusion is all reactive metals like of group 1 and group 2 are good reducing agents. Have you seen that you have written calcium as a reducing agent? Yes, Michelle? Calcium is a reducing agent. And what is calcium? It's a metal. So that means metals are a reducing agent. Yes? Okay. Now, the next one. Are you listening to me,
Yeah.
Michelle? All right. So, all good metals, like, for example, I'll give the example as well. For example, group 1 and group 2. So this is group 1 is lithium, sodium, potassium, rubidium, cesium. So the all of these metals, these are the reducing agents. And now come to group 2. These are both are metals. All right, both are metals. So this is beryllium, magnesium, calcium, strontium, and barium. So these are also the reducing agents. So this is a very important line. All reactive metals are good reducing agent. Now point number 2. All all non-metals, especially group 7 and 6, are very good oxidizing agents. So the emphasis is on the word non-metals, good oxidizing agent. Got my point? Okay, so now group 7 and group 6. Oh dear. Group 7 and group 6. This is the next important word. So let me write group 6. This would be oxygen, sulfur, selenium, tellurium, and polonium. And group 7, fluorine, chlorine, bromine, iodine. So they both are non-metals. They are both non-metals, and these are the oxidizing agents. So oxidizing agents, and these are also the oxidizing agents. Does it make sense, Michelle?
Yeah.
All right. Now have a look. Now, if you will ask me which is the best reducing agent in group 1, so always keep this thing in mind. The one at the bottom, these are the best reducing agent, because you know that the reducing agents are the one which are going to lose the electron very quickly. And we know that as we go down the group, atomic radius increases, and it is easy for the metal to lose the electron. So these are the best reducing agents. Now, if you talk, I hope that you are getting what I'm trying to tell you. Yeah. So these are the best reducing agents. Same thing goes here, that these
Yeah.
two are the best reducing agents. They all are the reducing agent, but the best reducing agents would be found at the bottom. All right, now comes the next one, that is all non-metals, especially group 7 and group 6, they are the good oxidizing agent. Now, where you are going to find the best oxidizing agent? Yes, Michelle, tell me where you will find the best oxidizing agent. What does an oxidizing agent do?
Um,
Michelle, what does an oxidizing agent do?
I don't know how to explain it.
Why you don't know how to explain better? You know what would be the definition of the oxidizing agent? It's written right in front of you, Michelle. It's there.
Yeah. So like, it's basically when it oxidizes the other.
No, no, Bete. It's right in front of you, Michelle. Oxidizing agents gain electrons. The thing which gains electron quickly is called as oxidizing agent. That's why I told you simply memorize the definition of oxidation. The opposite of oxidation would be reduction. The second trick is after writing oxidation, put a slash and write reducing agent. So, whatever are the definitions of oxidation, the same are the definitions of the reductions. All right, and here reduction is written. So, these are the four definitions of reduction, and these four definitions they apply to oxidizing agent as well. So, if you are going to memorize this line and only one part, all the picture will get clear in front of you. So oxidizing agents are the agents which gain electron quickly. Now, when I talked about the non-metals, especially group 7 and 6, they are very good oxidizing agent. So that means they all are very good oxidizing agent, which is going to take up the electron very quickly. The thing which has the smallest atomic radius will take up the electron very quickly. So the atom having the smallest atomic radius will take up, take up slash gain electrons very quickly. So have a look here. Which will have the smallest atomic radius, Michelle? I'm talking about group 6 and group 7, which is going to have the smallest atomic radius.
Um. I don't know.
Come on, Michelle.
The
Which,
last one.
no, the atomic radius increases down the group, beta. You know that, Michelle. The atomic radius increases down the group as you go down. So oxygen has the smallest atomic radius and polonium has the largest atomic radius. I do remember in one of our lesson you were telling me that atomic radius increases down the group. Michelle, you need to revise the notes better. If you are not going to revise it, it will be difficult for you to keep the information in your mind. You have to revise it frequently. Otherwise, or it would be difficult to digest all the knowledge. Now, you know, once you told me that as we go down the group, atomic radius increases. So, fluorine has the smallest atomic radius. This has the smallest atomic radius. All right. And this one has the biggest atomic radius. What is atomic radius? Size. Are you getting me, Michelle? Michelle, can you
Yeah.
hear me? All right. So, which one is the best oxidizing agent? Please keep this thing in mind. Fluorine is the best oxidizing agent. Best oxidizing
Because of the
agent.
size.
That, yeah, no, because it, not because of the size. The size is one element. That is, it is because it gains the electron very quickly. Fluorine gains the electron very quickly. I have showed you the definition here. Oxidizing agent is something which gains electron quickly. Here it is. Which gains electron quickly is called as the oxidizing agent. So fluorine being the smallest, the nucleus will have greater hold on the electrons, and because the size is very small. So if some electron comes in the vicinity of fluorine, fluorine attracts that electron towards itself. That is why fluorine is is electronegative in nature. All right. So this is the best oxidizing agent. So that means you can connect electronegativity with oxidizing agent. That is, the element having a greater electronegativity is, or would be the best oxidizing agent. These conclusions, you will not find these conclusions in any book, Michelle. These conclusions which I am drawing. Have a look. These conclusions. Conclusion number one, conclusion number two. You will never find these conclusions in any book. Now, I'll write it as a third one, third and fourth. So this is third conclusion and this is fourth conclusion. So please give due importance to these things. They are going to make your understanding very clear. Okay, so this would be now the atoms having the smallest, the whole line is very important. The atom having the smallest atomic radius will take up electrons very quickly. All right, and the element having a greater electronegativity would be the best oxidizing agent. So the atom having the smallest atomic radius will take up the or gain the electron very quickly and is the best oxidizing agent. Okay. All right. So these are in case of group six. Which one would be the best oxidizing agent? Michelle, tell me.
In group 6.
Yes, I've told you about group seven. Michelle, kindly tell me what would be the best oxidizing agent in group six.
In group 6, the best oxidizing oxygen.
Yes. Well done. Well done. So the best oxidizing agent is oxygen. So do write best oxidizing agent. Best oxidizing agent. Is it clear? Okay. So this was about the oxidizing and reducing agent. We have completed the whole two main topics of oxidation and reduction and oxidizing and reducing agent. So now the punchline is, or the important line is, reducing agent give gives away electron and oxidizing agent accepts electron. I have already written it. Where? Here. Have a look. Gain of electron. Here. Gain of electron. So I told you many times that oxidizing agent gains electron. So I have written here again. I hope it's clear.
Yeah.
Okay, now the next thing. The next important thing which is given in your syllabus is the half equation. Here, here. Now we are going to do this. Write, write the half equations for these redox reactions. Now, please write the half equations. I am going to rub this off. Now you will make me write down the half equations. Or what I can do, I can paste again. Okay, just a minute. I'll paste again. I'll stop share and yes, can you see the screen? Yes, Michelle? Hello.
Yeah, I can.
Now do this question. Write the half equations for these redox reaction.
Okay.
For this reaction. Now tell me, we have already done that. I have made the half equations, but now I want you to do the half equations.
I know. I know how to do this. Just give me a second. I'm just
Sure,
working
sure.
on it.
Sure, sure. Take your time. Take your time. Are you done, Michelle?
Really.
Do tell me when you are done.
Okay, so I got for CA and then CA2 plus 2E minus and then BR2 plus 2E minus equals to BR minus.
No, 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 no. You need to tell me separately which element has gained electrons. Now, half equation for this. Yeah.
So the
Now,
oxidation for CA,
no, I'm asking for the gained electrons, Michelle. I'm asking for A
BR,
part. A part.
BR,
Yeah, for A part, make me write down the half equation.
BR2 plus 2E minus 2BR.
BR2. All right. BR2 plus 2E minus 2BR. Well done. Good girl. Now, which element has lost electron?
CA,
Ca. Now, make me write down the equation.
CA, and then CA2 plus 2E minus.
Plus 2E minus. Well done. Now, which element has been oxidized? Which has been oxidized?
Calcium.
Calcium. All right. So, same equation. So, calcium solid changes into calcium 2 positive plus 2 electron. Which element has been reduced?
Bromine.
All right. So, same goes for bromine. Br2 plus 2E, 2Br negative. Now, what is the oxidizing agent?
Bromine.
Bromine. Well done. So, as you know, what have we written? That oxidizing agent accepts electron, yeah? So, you are going to see bromine, which is an oxidizing agent. It is going to accept the electron. So, accepting electron, and it changes into bromidine. And then reducing agent. What is the reducing agent now?
Calcium.
Calcium. So calcium, what is the reducing agent? Gives away the electron. Can you see this? Gives away the electron. So we have already done this. Here it is. Uh, Here it is. Loss of electrons. So reducing agent loses electron. So the same goes here, that what is the reducing agent? Calcium. And calcium is going to lose the electron, Ca2 positive plus 2 electrons. So calcium is losing electrons. So these are the half equations for these redox reaction. And this is the redox reaction. This is the overall redox reaction. How can you make it? Well, you need to add these two equations up. Add them up. I'm writing it here. Br2 that means first write down the oxidation equation. So that is, I'll write the oxidation equation first. Okay, just a minute. So oxidation equation, write oxidation equation. So what would be the oxidation equation? That would be Ca solid changes into Ca2 positive plus 2 electrons. Okay, this is the oxidation equation. Now comes the reduction equation. So the reduction equation would be Br2 plus 2 electrons changes into 2Br negative. Now add these two equations up, add them up, and you are going to get, when you will add them up, you are going to get a redox equation. Now this equation, which I am going to write, is called as redox equation. How come? This plus 2 electrons would be cancelled by this plus 2 electron, and now write these pieces towards the reactant side. This would be cancelled with this, and the product species towards the product side. So these two are the products. So you will write Ca solid plus Br2 gas changes into Ca2 positive. All right, and Ca2 positive plus 2Br negative. So this is the whole equation, which is called as redox equation. Are you getting my point?
Yeah.
Is it all clear? So this is
Yeah.
the oxidation equation, this is the reduction equation, and this is the redox equation. I hope it's all clear.
Yeah.
Any confusion, please?
No.
No? So this is your lesson today. Uh, I'm going to scroll down very slowly so you'll have the idea that what did we do in the whole lesson. And then I'm going to post some questions so that you can do them. All right. And please memorize these conclusions. These are this is the excellent resource. All right, so these are really good points. So now this one also, and don't forget to cancel out the electrons. All right, I hope everything is clear. Yes, Michelle? Okay,
Yeah.
we are going to continue the same chapter in the next class, all right? And be very careful in the next class and be very vigilant and attentive, because we are going to do a tough topic, that is how to make the full equation. Okay, it's the given in your syllabus. Okay, all right, Michelle, thank you so very much. Any question, Michelle?
No.
All right, okay, beta. See you.
Thanks.
Bye bye.
Bye.
Bye.